Oh man, it's pretty funny. I thought I had enough videos of this arbor press, but apparently not. So today's video is actually quite tragic, but I think it's gonna make for a great video. So that's really what matters for you guys. So we had this arbor press perfectly restored to the best of my ability at the time, and that was only a couple months ago, and a problem came up that I just couldn't live with. And today we're gonna fix that problem, and I'm gonna share with you the realities of restoring a machine. And sometimes it goes well, and sometimes you gotta go back and fix things. And that's what we got going on today. So let me bring you around to the side and show you what we're gonna fix. One of my goals in making this video is to not only show you the mistake that I made, but hopefully help people understand the nuance when it comes to doing machinery restoration. Most of the machine rebuilders follow a very similar pattern when they're rebuilding equipment. They bring the machines in, they pull everything together and inventory everything, and they inspect the equipment and make meticulous lists of all the parts and pieces that are broken. Then they disassemble everything, make the parts necessary or repair the parts necessary, get everything painted, scraped if necessary, and then reassembled, and all looks well. And that works out most of the time. But sometimes problems don't manifest themselves until you have the machine in a running condition and can test it. And that's exactly what happened here. When this came to me, it was missing a handle, and it had some issues with the gear paw, and so I wasn't able to use it, and my best way to inspect it was just to visually inspect it. So when I got it back together, everything did work fine, but what I had was an issue with the side handle. So the side handle took 2 hands to operate, and it did work just fine, and it still worked up until a week ago just fine. But I really wanted it to be real smooth and easy. I had another arbor press that you guys may have seen, and that one, the handle was really easy to operate, and when I loosened the nut, the rack basically fell down. It's real nice and real easy to use, and that's how I wanted this one to be. And I think that makes using an arbor press very enjoyable because this is a very tactile piece of equipment, and having a handle that goes up and down easy makes it enjoyable to use. And this one was pretty stiff. And so I did take it apart initially when I put it together the first time and came in here with a flap wheel and cleaned up the bores because I originally thought that the shaft was catching. And the inside was pretty rough. And you'll see, I'll give you some close-ups, there's some galling in there. And I was hoping that that would help, and it didn't help. It just continued to stay stiff. So I used it for a couple months and hoped it would get better, but it didn't. And to be honest, for 90% of the people out there, it's completely fine. But I really wanted to make sure that this operates as good as it can, especially with all the time that I put into it. So finally, I had some extra time last week, and I thought, you know what, let me take it apart and let me get into it, and let me really clean it out even more and put it back together, and we'll be fine. And the reason I thought that is because the wheel would move freely and then it would get stuck. It would move freely and then it would get stuck. And so that led me to believe that the shaft going across here may have been bent and may have been catching on the inside of the bore at certain positions. So I wanted to pull it apart and make sure it was operating better. Let me bring you around to the side as I continue to explain this and why that was wrong and how we're gonna fix it. So here's a better shot of the bore on the inside, and you can see there is a lot of galling. And the first thing to notice is that the galling is in the same direction, right? This is a rotating shaft, and typically when something galls, it's gonna gall in a rotational fashion. And there is a little bit of galling in this way. So you gotta kinda wonder, well, how did this get here? Well, the way this is installed, and I'll show you, the rack gear, or whatever you want to call this thing, comes in, and the gear is sized similarly to the bore. So when this comes in, and I'm kind of standing at a weird angle, there we go. What I think happens is as people have used this and installed it and uninstalled it, these teeth have kind of caught on the edge of the bore, because when this comes in fully, the teeth are on the inside and they don't touch there. That's just a theory, I don't know if it's true. But basically it caused a bunch of galling perpendicular to the rotation of the shaft. And it was my initial impression that what was happening was the shaft was catching on this galling intermittently as it turned, right? I guess it's not technically intermittent, but it, once or twice per revolution, and caused the wheel to kind of bind at certain points. And I also thought that the part that I just installed was bent, and it was bent. I got it up in the lathe and I checked it, and it was out 20, 30 thousandths. So what I did do, and you probably can't see it, is I went ahead and I took that shaft, I got it set up in the lathe, and I recut the end of that shaft down, set it up in the 4-jaw chuck, and that shaft is now not running out at all. But it's not running out at the cost of making this side of the shaft narrower. Okay, so we did that. So now the whole shaft is running true, but now this side, the hole was way too small. So what did I do? I went ahead and I turned up a bushing and I pressed it in here, and I have it secured with a slight press fit and mostly some of the green retaining compound. And then on the other side, I made another bushing and pressed it in from this side. So now I have continuous support all the way across, and I know for a fact that these bores are in line and they're a nice tight fit. And I thought that that would solve the issue, and it didn't. And what I came to realize is that we had multiple issues going on here. Not only was this shaft bent, and I'm going to insert it to kind of show you the issue. Not only was it bent, which we addressed, not only was it loose in the hole, which we addressed on the other side, but it was loose in the hole on this side. And when I get this fully seated, I don't know if you can see this, I can measure it with an indicator, but I'm going to guess 40 thousandths. That's my guess of up and down play. And that play is a problem more so on this side for one main reason. There's a bunch of weight that sits on this side. You have the counterweight, you have the handle, the paw is pretty light, and it sits on the outside of the shaft. And so what happens is I kept fixing the concentricity of the shaft, the bores, everything was smooth on the other side, but I did nothing on this side over here. And what was happening is as I was using it, this shaft is being pushed down and it's basically flexing. And because there's so much slop here, it's dragging on that rough surface and it's causing an intermittent sticking, or at least that's the theory. So in order to test this, what I did is I hooked up a jib crane over to the counterweight and I actually pulled up just slightly to take pressure, and the handle operated nice and easily. So I feel pretty confident in saying that the issue with this whole entire thing lies in the bore that I just showed you. And I know it seems pretty obvious, oh yeah, it looks bad, but you have to understand, just because we're seeing a problem doesn't mean it's the problem. I already chased down 2 other issues with that shaft and with the other bore thinking it was going to fix it, and we didn't touch it at all. Nothing changed at all. So I think this is the last thing that we can address, and I think it's the most important, and I'm really hoping that addressing this is going to help get us to where we need to be, to where this is a nice tight fit, and that tight fit is going to prevent any deflection of this shaft, which will in turn keep everything together and keep everything from binding, and it will operate smoothly, or at least that's the hope. I know this is a little long-winded, but my goal here is to help you guys walk through my thought process and see how I diagnose these things and think these things through. This next part brings us to the fun part of the video. How are we going to fix it? Now, the other ones were really pretty simple. We take the shaft, we make it smaller, and we press in a bushing and we move on. Now, unfortunately, because the way that this shaft is set up, on this side, that's not possible. And that makes our lives significantly more difficult, because instead of pressing a bushing into here and turning the shaft down, really what we have to do is we have to machine this bore. And really the best way to do that is line boring. And I've been dying to do some real line boring for over a year, and we finally got our first real line boring project that we're going to shoot in the shop. And that's what we're going to do. So we do have a bushing from McMaster-Carr that I got that we are going to be pushing into here and using some thread compound or retaining compound to hold it in place. and some pressure. But we do need to go ahead and get this thing line bored out so that way we can get this pushed in. And I do got to take this over to the lathe and clean up the OD so that it matches our shaft. But we do need to get this line bored. And line boring something like this is a little bit tricky, but we're going to get it done. And it's tricky for a couple of reasons. The first part is this is cast. So if you watch a lot of line boring videos, typically what they'll do is they'll weld their extensions or spacers onto here and set up their bearing blocks. I think it would be fine, but I also know welding to cast is not really ideal. And the way it's normally set up, I just don't feel comfortable doing it that way. So we're gonna do something that I'm sure has been done before, but I don't know how else we would do it. So what we're gonna do is we're gonna drill and tap several holes around the perimeter here, or maybe up here, I'm not sure yet, and we're gonna thread in some studs. That'll give us some mechanical adhesion to this piece of cast iron without overly deforming or preheating or doing anything crazy to this already finished part. Then once those are installed, we're gonna put on our plates with our bearing support on this side and then weld those studs to the back of the plate. So it'll be a mild steel to mild steel connection. And then we'll go ahead and get our brand new mag drill set up and get this line bored. So I'm really, really excited to do this. I've been wanting to do some line boring for a long time. This situation is pretty unfortunate because I really don't want to go backwards in the restoration process, but I think doing this is going to give us a really nice fix, and it's going to give me an excuse to give you guys a great video and also get to do some line boring for the first time. So the next step of this video is going to be setting up for line boring and talk about what we're going to be using and show you how we're going to get it done. We're over here at the bench. I want to review the setup we're going to be using to do the line boring. So first and foremost, we're going to be line boring with this beautiful HMD 920. It's a brand new mag drill to me. I'm really excited to use this for the first time. And of course, like a lot of things I do, the first job for it is going to be difficult, challenging, and it's going to be vertical position, which is fun since it's super heavy. So that'll be great. We're going to be using that. Now, in order to attach that to the line boring bar, we're going to need an attachment point, and these mag drills use this 3/4 inch welded shank style. There's just like a sample of it on an annular cutter. So what we're going to be doing is making another line boring bar and machining down the end with this similar style shank. Now originally I was going to use the line boring bar I had for obvious reasons, meaning that I don't want to make another boring bar. So I had purchased 1/2 inch tooling and the proper inserts to do that, and I got a bearing block. However, I figured out that the clearance wasn't going to allow for the bigger bar. So we are going to be making a new bar, which is why we have this in front of us, and we're going to be using one bearing block that is for 1.25 inches, and we're going to be doing a whole new 1.25 inch bar. And instead of doing some broaching, which we're not going to be able to do because my press is down, we're going to be just drilling holes and using an actual boring bar. And that's going to do two things. One, it's going to make making the boring bar a decent amount easier. And two, instead of using this tooling where the insert is not on center, it's going to allow us to use these boring bar style inserts where the actual cutter is on center, which means that we can drill our holes in the center and the cutter will still be on center, so the bar can be used in either direction, which is really nice. So just a couple of notes on the actual setup. We're going to need 3 parts to make this work. The first part is 2 bearing blocks. I could get away with 1, but I'm going to do 2, and I'm going to be making them with these bearings. It will be job specific. I'm not going to spend an exorbitant amount of time making it because I'm just using it for this job, and it's not going to be too relevant on future line boring jobs. But they're going to be inserts that slide into the bushings or the bore that's existing and hold this bearing so that this can pass through. That's one part we need to make, even though it's 2 pieces. The second part we need to make is the line boring bar itself. So we need to get this bar drilled, we need to get the end made. We're going to do that. And then the last part is we need to make an attachment block for the actual mag drill. So it's just going to be a base It'll have a bearing mounted to the back side with one of these bearing plates, and it will be ready to accept the mag drill and attach the mag drill to the actual arbor press. So we're going to start out by making one of these 3 parts and go from there. All right, we're going to start on the bearing block. I did find this scrap in my scrap pile. It's not the exact size, but it'll save us a lot of work. It's already got the narrow end and a fatter end, and it's one piece. So we're going to get this chucked up and drill a hole through the center and get started with that. All right, let's get started with a center drill and go from there. Come in with a pilot drill. We'll use a 1-inch drill next. Let's get that front faced off. All right, we're going to get the front board out. Nice healthy cuts there. Take this cut and then we'll measure after, see where we're at. All right, we got the fit dialed in and made our final pass. It will go in, it's going to be a tight fit, but it will go in. So I'm going to pop it out and we'll move on to the next step, which is getting this guy flipped around and finish out the back. Probably what I'll do is I'll heat this up, slip the bearing in, and then when it cools, it'll grab onto it. And then when we're done with this, if we want to recover the bearing, we can warm this up and drop the bearing out. All right, looking good, looking real good. All right, let's come in here and then just machine this down to our final dimension. Come in here and touch off. I'm going to take a lighter cut so that we can get a measurement and know that we're a little more accurate. All right, we're going to take another 15 thousandths. Just take a spring pass. Our final pass there. All right, we got our one bearing block done, and then I went ahead and got another one done as well. So they don't have to be pretty. The ID just has to fit inside there, and the OD has to fit the bearing. All right, we got our first bearing in here. Let's get it installed. It should be a really nice tight fit, but should go in. It's a really hard thing to do. to get that tolerance just right, because I want to be able to get it back out. I don't want it such a hard fit that I can't get it out. Get a hammer and a piece of aluminum. Let's see, are we going in? I think we are. Wow, look at that. That is a perfect fit. Just enough resistance to keep it from spinning, hopefully, but tight enough to where should be mostly concentric with the hole, and we're kind of relying on the lathe, and that's why we did these and finished these both out in the blue lathe, because the 6-jaw chuck is pretty concentric. It doesn't need to be perfect, but I'd like it to be within 1/1000th or so. That'd be nice. We'll know just how good it is if we can slip the bar in there. That'll be the test. This one seemed like it could be a little bit tighter, maybe not. Oh no, that looks perfect. Wow. Wow, that is nice. That's real nice. Oh, our bearing is a little looser than I thought. Maybe because it cooled down. Yep, probably. We'll put some retaining compound on it. It is a tight fit, but get some retaining compound on that and we should be good there. All right, here's the moment of truth. I went over to the lathe and put a chamfer on the bar to make it easier to slide in, and we'll see. That's tight fit on the bearing, that's good. All right, I think we're on the other bearing. Hopefully it's not super tight fit, and it is, but we are making it through, which leads me to believe we are reasonably in line. Very minor tapping, and we're through. All right, we're spinning. I would love for it to be a little bit more loose, but this will work. Kind of the benefit of having this second bearing back here is just to add a little bit more support and keep everything in line, so that way when we go to mount the third bearing, we have a reference and we already are in line with this bore. So even though it's a little on the tighter side, I think it'll be perfectly fine. So next step is to go ahead and work on the boring bar and get that taken care of, and then we'll move on and make the actual plate. Okay, so for the boring bar, I'm not gonna go into too much detail. If you wanna see how to make a boring bar, I'll leave a link up in the card. I already made a boring bar not too long ago, and the point of this video is the line boring, but I did wanna show you making the bearing cups and making the base at least briefly. So I'll go ahead and make this off camera, and then we'll bring you back and move on to the next step. All right, guys, getting really exciting. It's starting to come together. So the boring bar, I went ahead and made off camera. I did a 24-inch bar, just thought a nice short one would work. And then we did 1/2-inch 20 set screws so that we have a nice lot of leverage there. And then I have my bearing block just kind of sitting on here where it's gonna be. And this is kind of what's gonna happen here. So the block will come up. I'm gonna have a plate that's bolted to this block. We'll have studs going into the actual casting, and then the mag drill will sit on here and adapt right over here at this Weldon style shank, and then our cutter is gonna come in here. Now right now I have the wrong side. I have the cutter that you'd use if you ran this in reverse, but I ordered a bunch of the correct ones yesterday and they are waiting for me at my house. So I ordered 3 of them because I figured I'd be cutting them down and it'd be nice to have extra ones on hand. This is looking real nice. And now that this is set up, you can kind of see the benefit of having 2 bearings over here. Technically, you really only need one on either side, one here and one there. But the benefit of this is these 2 are setting the position of this bore. And so what it's doing is it's ensuring that the bar is sitting in the right place. So when I come and slide this on and mount the plate and weld it to the plate, this position will already be located off this. Now what I could have done is skip this bearing and made a cone and found this bore, and I thought about doing that, but this does 2 things. It does add extra work, but it gives us another little bit of support over here, which may be necessary if we were to have the bar stick out too far. It may have extra vibrations from flopping around, and also it just helps us keep everything lined up real nice. I'm hoping the distance between this bearing and this bearing isn't too far, but I've never done this before, and it is cast iron and we're gonna be taking light cuts. So I think we're gonna be fine, but I think this kind of shows proof of concept. And the next piece is to manufacture this plate. That should be pretty straightforward. I want to integrate some sort of feature into that plate to allow the mag drill to strap to it. That way, once this is all welded and in place, if we lose power, we're not relying on the chain on the mag drill. So let's get to making that plate and then we'll move on to the next step. All right, we've made some progress on the base plate here off camera. I didn't show much of it. It's pretty redundant stuff, just a lot of drilling and tapping of holes on some plate, nothing too exciting. So what we got going on is the mag drill is going to sit on this plate. It's 12 inches, I believe it's 6. And then we have some holes tapped for a bearing block that's going to go on the back side. And then like we talked about, I want to make sure that there's something to clamp the drill down. So what we did is I turned up 2 of these spacers. They're threaded. And then I reamed these holes. So these are a nice press fit. So what I'll do is I'll take a hammer, tap them down, and then I will bolt this across both of them. And then on the back, I will do a plug weld. And what that will do is that'll minimize distortion and prevent me from having to do a weld around the perimeter here. That'll be nice. Once these are flush, they sit about 20 thousandths lower than the deck height. So when we put these on, it'll clamp this down and be really, really secure. And then we got a little notch for our lock there. So it turns out real nice there. Over here, you probably noticed we have a drill chuck on here. So Hugin sells a drill chuck, but to be honest, I wanted to use a super chuck. They're just a much better quality chuck. So I want the biggest one I could possibly fit, which is a 16 inch. But in order to make it fit and make it come all the way down to the bottom, I actually had to turn a section of the chuck down. So off camera, I went ahead and pulled this apart, put this over in the lathe, turned it down, and ended up rebuilding this chuck, cleaning it out, and now it operates real nice. This is a little bit overkill, but it's good because if I want to do any tapping in the chuck in the future, having a nice beefy chuck will really make a difference. So the next step is I may go ahead and cut this out. I may not, I'm not sure, but we'll get these studs welded in. I'm going to put a little support on the back for this to rest against, but for the base plate, we're pretty much done, and then we can start getting it installed on the Arbor press and do some line boring, which we've all been waiting for. All right, we got the base plate done. I went ahead and just milled this out. No real reason, just to lighten it up. And then we went ahead and welded a piece on the back. And then we got all these plug welded in. We got our bearing on here. Everything looks nice. Next step is to go ahead and take this all apart, put on the chuck, and go over to the Arbor press and start drilling holes. That's the way that we're going to attach this onto the casting. And we'll talk about it more once we get over there. All right, next step is to get the holes drilled here. What we're gonna do is drill and tap for half 13. I have a bunch of these. They're old and I don't use them. So we'll thread these in, get them tight, and then cut them off to 2 1/4 away, or maybe a little bit less so we can do some weld buildup. But that's the plan. Now normally, this would be something I just do with a hand drill, but we have a mag drill. So this will be the first job that we're using it for, and of course, it's kind of a pain because we got to get it up here at an angle. So I thought it'd be kind of funny to watch me maneuver this thing. I do have it on the jib crane, so let's see how hard this is going to be to set up. Maybe not as bad with the crane, but we'll see. Yeah, it seems like this way is the better way. I can just tell you, I'm not sure that I'd want to set this up without a crane. Not sure it would be possible. So I'm going to just kind of get this close, and we have a swivel base. Okay, I just locked it. That's not confidence inspiring, but that's all right. So all right, so we got it in place. I'm not fully on, as you can see. I got some stick off, but on this mag drill, it does get 30% stronger once you apply the power, and I think we'll be fine. But we have the crane up here for safety, and we have our 29/64 drill bit. And I'm hoping that this will just make this a dream. So anywhere in between a dream and more convenient would be acceptable. All right, I'm gonna come in here with our chuck key and get this tight. And this is where I really hope that this swivel base really comes in. Let's see, unlock is forward. Yep. It looks like we're close. We're not exactly where I want to be, but I think we are within range. All right, we're close. We're not dead on, but this isn't an exact science over here. We're just trying to get some holes for our studs. All right, let's see how this baby works. All right, let me get some of this stuff blown out and we'll see how we're doing. Careful there. All right, let's get our drill bit removed. And while I'm doing this, I'm just gonna talk about why we're doing this. So typically you'd weld your studs to whatever you're line boring, but because this is cast, I just don't feel comfortable doing it. So I'm gonna tap these holes and thread them in. I think it'll be a little bit more durable that way. Let me grab a tap. Obviously a tap driver would be recommended here, but this should work. They do make a tapping attachment, but this will work for what we want. I'm gonna get it started. I'm not gonna go all the way down. I'm gonna finish it by hand, but I wanna get the alignment where I want. I'm gonna shift into 250 RPM, and we're gonna start it, and we're gonna get started, and then I'm gonna stop it right away. Well, we'll see how this goes. A little fast, I'm gonna be honest. Oh, that's one way to do it. I think it's a little quick, and there's some pretty good gear reduction, but in this case, I just stopped it and ran it in that way. That way it's kind of on the down stroke of it closing down. All right, so I think that's gonna get me where I wanna be in terms of alignment. So I'm gonna do the other ones and then we'll finish these out. Actually, I remembered that I have some tap sockets, and so I think we'll just finish these out as they are. All right, there's the bottom. And we'll come in here with a bottoming tap once we're done. That did work. And I know we got a lot of people that are gonna say, hey, do it this way in the comments. That's fine, I would love to hear that. Just keep in mind, this is the first time using a mag drill. I'm tapping and drilling at an angle, and I'm learning all at the same time. So keep that in mind. All right, we got a tapped hole there. I'm gonna get this back to center, that way we have some adjustment and we're not maxed out. Okay, all right, we're gonna disengage the magnet. All right, let's see where we're at. Not bad. There we go. I think that's gonna be good right there. See what I mean about this clearance? I wanted to get real close so that if I'm using a tap, I can get right up there. Let's back this puppy out. Get our 29/64 drill bit. All right, we got everything set up for hole number 2. Here we go, we got a fresh bit in there. Oh yeah, that's drilling way better. Had a chip drill bit and it was causing some issues. And we'll come in here with our tap, and you may have noticed that I forgot to lube it up, which I did, but cast iron does have a lubricating property, so it's not the end of the world, but we'll throw some lube on it this time. I have this Anchor lube, but for whatever reason, my bottle, the cap is not good. I've already drilled it out multiple times. It just keeps getting clogged. So we're gonna try that similar strategy we tried. We'll get it going at 250, and then we'll shut it down and then plunge it in. Good, that worked good. Excellent. Holes straight and good to go. We'll get that blown out and then I'll bring you back when I have all these holes tapped out and then we'll go from there. Let's go ahead and get these studs screwed in. Just gonna use some Knipex Cobras here I love these Knipex. Make sure we're nice and tight. These are just some old threaded studs. I have way too many, so I don't have a problem destroying these. Plus, it's just one less thing I gotta make. Had to make so many things for this project. I'm certainly hoping this will be rigid enough, but we'll find out. Let's go ahead and get this bearing block on here. It's to go on exactly square. There it is. Now, because this bearing is spherical, this plate could go on in any angle, even though the alignment is good. Wouldn't affect anything except for when you go to feed it, the feed would be at an angle. So what we're gonna do is put some 1, 2, 3 blocks in here because this face is milled, and then we'll get this square to this face, which should be good. All right, guys, we got the mag drill set up and we're getting ready to do our first cut. We got the plates welded on and I went ahead and left my spacers in there just to give a little bit extra support. And I went ahead and made an Arbor extension here so that we can reach the boring bar and we get a little bit more travel out of the mag drill as opposed to using the base. Let's get to drilling. Well, guys, that worked out really, really well. We ended up just taking one pass and we're within like about 20 thousandths of where we need to be, so I'm just gonna stop right there. We used a CCGT insert, which is recommended to me for line boring, and it did a really nice job cutting through. The surface finish on the inside isn't the greatest, but I'm not worried about it because we're gonna be pushing a bushing on there, but it is nice and true, and it is a nice even cut, which is what we want. So we're gonna go ahead and get this disassembled. Kind of sad, I've spent probably 30 or 40 hours making these things, making different supports, making the line boring bar, and obviously modifying the mag drill. And we only spent probably 1.5 or 2 minutes making the cut, but that's pretty typical for machining. And next time I go to do this, I'll have the stuff already done, which will make it a lot easier. So let's go ahead and get this disassembled, get our bearing plates off, and go ahead and take a look at the bore and move on to the next step. All right, here's a shot of the bore. We got the plates removed. Overall, not bad. We do have a couple spots in here where I messed with the feed and wasn't consistent, but other than that, I would say it's pretty good. The inside diameter is 3.605 and the bushing that I have is 3.620. So I'm just gonna get the bushing chucked up in the lathe and turn off 15 thousandths. I want this to be a press fit, but not too tight of a fit because I wanna be able to tap it in. And then we'll use some retaining compound. So I'm gonna make it right on size, and then I think the back of the hole maybe is 0.5 thousandths larger, probably because of cutter wear. So that'll help hold it in place. And if nothing else, we'll come in here with a whizzer wheel and just kind of tune it in so it's a nice fit. Overall, real happy with how it turned out. All right, I got my bush chucked up. We got a CCGT insert, nice positive rake. Running 1200 RPMs. I'm gonna touch off. I'm running 630. I need to come down to 605. We're doing a touch off there. Just gonna take 10 and see how we look. I only need to come back about 3.5 inches. This is a 4-inch standard bushing, so I don't need to come all the way to the chuck. It's a nice finish. All right, DRO is saying 36.19. We'll measure it and see where we're at. We're gonna take another 10 thousandths. We're just taking a cleanup pass here. Should be right on the money, if anything, maybe a little heavy, which is good. Maybe like 2 to 3/10 oversized. I don't want to make it too small. All right, we're just doing some deep boring here, using an anti-vibe boring bar. Try to cut down on the vibrations. There's a little bit of chatter, but honestly the finish isn't too bad. And also this is oil light. So there's like an oil impregnation on the inside, and so the chips stick to it. All right, we got the bushing done, and then I pulled it out of the freezer. So we're gonna get it in, and hopefully it goes in. Nice. Oh, that is perfect. That is literally perfect. Just enough resistance, and as it warms up, it should be a nice fit. I had it cooled down to about -40 or 50. So as it warms up, that should be plenty to hold it in place. We're gonna come in here and hone this. It's about 1 to 2 thousandths undersized, so we'll hone it and we'll get a perfect fit. All right, we're gonna remove this bearing block. All right, making some progress there. Playing hard to get, but that's fine. All right, we're just gonna hone this and try to bring it into final size. After hours of polishing and fitting, I think I got the right fit. I'm gonna lube this up. Now this bearing does lubricate itself naturally, but I'll just put some whey oil on it. The clearance we're looking at is about 4 thousandths oversized on this, and I think 4 or 5 on the inner one. And I've had this shaft in and out probably 20 times just to kind of make sure it's a good fit. Don't want it too loose, but wanted to make sure it will move freely. I also machined this gear down like 10 thousandths or so lower than this, so that way it's not gonna drag going in and out. So I was hoping that would help. And then now we're coming onto the bearing surface. Kind of see that moves, but a little bit of resistance. And now we're in. All right, so that spins really nice actually. Hopefully not too nice. When it was spinning nice before, it wasn't working because it had too much slop. Up and down. I don't see any movement. I measured it earlier. I think it was like 3 or 4 thousandths. All right, so we are gonna assemble this and cross our fingers. I'm about 50-50 on this because I've been test fitting it, and early on in the test process, I didn't think this was gonna work. I'm a little more hopeful now, seeing how nice this is spinning, but in the beginning, trying to get the bores lined up, I mean, we're within a few thousandths, 2 thousandths or less, dialing this in between honing and sanding to get a nice fit, but something that's not too loose. So we'll get it back together and we'll bring it back and see if it worked. We're gonna be fixing another part on the Arbor press, which is just aesthetically bad. There's nothing wrong with it. Like we talked about earlier, I have some dimples here from some brass set screws. Even though this is hardened steel, they made a dent. So either they're not brass, they are some sort of set screw that's coated in brass, or there's something weird going on here. Nonetheless, I'm gonna change the design so that way we don't have our pressure points so narrow. I'm gonna widen out the pressure point, but since we have the Arbor press apart, I'm gonna go ahead and clean up the top just to make it look nice again. So if you're wondering, the answer is yes, you can use a milling machine like a surface grinder. And we did this before to get this great finish, so we're gonna do it again just to clean up these marks, and then we'll be good. Well, I'm happy to report our repairs worked out. It was a ton of work and we probably got a 30% improvement out of it, so it wasn't crazy, but I think it's enough to make a difference. And for a normal human being, it probably would have been fine, but I am pretty OCD, and I think using this and the experience will be much better as a result. You can kind of see when we pull the handle, the actual rack drops on its own pressure, and then with one hand, we can go ahead and raise it. Before, we were having to two-hand it, and also it would have like a rough spot, all right? Now it's nice and smooth. I tested it with the rack in, with the rack out. I have it set a little on the tighter side because I'm pinching on the side of here and on the front, so that way we have minimal movement either way. But the actual movement is really smooth. When I got it all back together, I was actually kind of surprised because the original movement was pretty notchy, and I thought it was the rack, and it's not the rack. It was the fact that the bore was pretty scraped up and out of round, and the shaft was bent. So now the action is nice and smooth, which is really, really, really nice. So we can actually bring it down where we need to. And I have it set to where if I bring it up, it'll stay, which is really, really nice. If I wanted to run it a little bit looser, I could, but you can see even just with a little bit of force, it will fall on its own, which is really, really nice. So overall, really happy with the way this turned out. I know this was a very long and arduous process, but I wanted to bring you along to show you kind of what does happen and how we fix it. And in this case, we had to do some line boring, which is a big feat in itself on this piece of equipment, and everything turned out great. If you like the video, please like, subscribe, comment down below. I know we're gonna get a lot of comments, people saying you should have done it this way, and that's fine. I wanna hear your opinions, and we will see you in the next one. Well, I'm happy to report this is working excellent. Before, I wouldn't be able to do that. And this handle is working really well. We made about a 30% improvement, so it wasn't crazy, but I think that little bit of improvement is gonna make using this a lot easier. Before I had to really take 2 hands and wrench on this, you know, now it's nice and easy. I can do it with 1 hand. And I have it set a little on the tighter side by pinching the sides and on the front so that this rack has minimal movement. So I could run it a little bit looser, but I got it right where I want it. So I'm very happy with the way this turned out. This ended up being a ton of work. We're talking 40, 50 hours between line boring, making parts, getting a mag drill, setting that up, modifying it, taking this apart, doing it multiple attempts. It took a really long time, but that's part of the process. Sometimes if you want it done right, you gotta fail, you gotta make mistakes, you gotta learn new things, and you gotta experiment. And that's what this video was all about. If you guys enjoyed this video, please let me know down below. If you have any comments or questions, post them. I'm sure we'll have some debates down there in the comments section, and we will see you on the next one.